Let's continue by looking at distributions. What is a distribution? It is a way of describing the frequency at which all the possible values of a variable occur. And for a representation to be a proper distribution, we must account for all values once and only once, and our total count must add up to 1 or 100%, so that all of the data is represented. This is the equivalent of asking that a probability density function integrates up to 1. So those two concepts are intimately related, and right now we're going to be focusing on graphical representations of distributions. Let's take a look at this figure and ask ourselves, pause the video, and do you think this is a distribution? This shows a distribution? Does it meet the criteria we just described? Well, the answer is no, because individuals, in this case, were asking what leisure time looks like between 2005 and 2015 for people 60 years and older. What do they spend their time on, and what activities are they spending more or less time on between those two, between 2005 and 10 years later? And it turns out that individuals can be in more than one category. Because people may have answered exactly for all of these categories what they do. And these numbers are not representative of frequencies of anything. They represent the time that people are spending more or less compared to 2005 on those various kinds of activities. So that was not a distribution. What about this one? If we ask if we ask US teens, what do they post about on their social media? Is this chart a distribution of what teens post on? Again, pause the video, think for a second. The answer is no, because while there are percentages, while these are the percentages of US teens who say they ever post about this or that, about their accomplishments, about their family. So 49% of teens post about their accomplishments, 44% post about their family, etc., etc. Those percentages don't add up to 1. If you actually add up, well, it's pretty straightforward. 50, 44, and 34, that already is well over 100%. And the reason is because respondents, and it says right here, were allowed to select multiple options because people can boast about more than one thing. So that was not a distribution. What about this one? The share of American adults in various income tiers. So yes, in this case, the answer is this is a proper distribution because we have an ordinal categorical variable, the income tier, which is for which there is actually a sense of order, where upper represents higher income than middle and represents higher income than lower, and individuals can only belong to one of them. If we assume that this was done based on whichever measure of income, tax returns, etc., they're going to land on one of these three, however they were defined. Obviously, these are arbitrary choices, but once those cut points are made, people will fall only into one of them. So for whatever pool of adults who were used as data, this was done, individuals will only fall into one category, and these values represent the fraction of the entire data set that falls into a category, and we can see that they do add up. They do add up if you add those numbers. They do add up to 100%. So this is actually a proper distribution.